Hey everyone, welcome back to the channel. I'm super excited about today's video because we are diving into one of the most powerful and often underused features of Amazon DynamoDB Streams. By the end of this video, you'll know exactly what DynamoDB Stream is, how it works under the hood, and most importantly, you'll build a real-world example using AWS Lambda that processes stream events in real time. So if you're ready, let's get into it. And hey, if you find it useful, a thumbs up and a subscribe really does help this channel. Alright, let's go. Here's what we'll cover today. First, a quick refresher on what DynamoDB is. Then we'll talk about what DynamoDB streams are and how they work. After that, we'll look at the different stream view types, explore some real-world use cases, do a hands-on step-by-step example with Python and Lambda, and finally wrap up with some best practices for production. There's a lot to cover, so let's move fast. Feel free to pause whenever you need to. Let's do a quick 60-second recap of DynamoDB for anyone who's new to it. DynamoDB is Amazon's fully managed NoSQL database. It's a key value and document store that's designed to handle massive scale. We are talking tens of trillions of requests per day. It gives you single-digit millisecond latency even at that scale. And it's completely serverless. It scales up and down automatically based on your traffic. It also supports multi-region active-active replication through global tables, which is massive for global applications. Now, all of that is great, but the question is, how do you react to changes in DynamoDB in real time? And that's exactly where streams come in. Alright, so what's DynamoDB stream? A DynamoDB stream is a time-ordered log of every item level change that happens in your DynamoDB table. Every time you insert, update or delete any item, DynamoDB writes a record of the change to the stream. Think of it like a change log or a transaction log for your table. And these records are retained for 24 hours. Now look at this flow diagram. When your application writes to a DynamoDB table, whether that's an insert, a modification or a delete, DynamoDB almost instantly creates a stream record capturing that change. A consumer process like an AWS Lambda function then reads that record and takes action. A few key things to know. Streams are near real time, typically within 2 seconds of the write. Each record is delivered at least once and in order within a shard. And streams integrate natively with AWS Lambda, which makes them incredibly easy to use. Before we look at use cases, let's talk about stream view types, because this affects what data you actually get in stream record. There are 4 options. The first is keys only, where the stream record only contains the primary key of the changed item. This is the lightest weight option and is great when your downstream process just needs to know which item changed and not what the data is. Next is new image. This gives you an entire item as it looks after the change. Perfect for syncing data to the search index like Elasticsearch. Then there's old image. The entire item as it looked before the change. This is your audit log. Great for rollback scenarios. And finally, the most complete one, new and old images. You get both the before and after state. This is best for business logic where you need to compare what is changed, like checking if a specific field was updated. You can change the view type at any time on an existing stream, but existing unprocessed records stay in the original format. Now let's get to the exciting part. What can you actually do with the DynamoDB streams? The answer is a lot. Cross-region replication. You can use streams to replicate changes to DynamoDB tables in other AWS regions for disaster recovery or to serve users with low latency. Event-driven notifications. Imagine an e-commerce app. Every time an order status changes in DynamoDB, a Lambda reads the stream and fires an SMS notification to the customer. Zero polling, pure event-driven. And then we can use it for search index sync. DynamoDB isn't great at full text search, so you can use streams to push every change into Elasticsearch or OpenSearch automatically, keeping them in sync without any extra application code. Data aggregation. You can compute running totals or counters in real time as items change and store results in a separate aggregation table. Audit trail and event sourcing. Every change gets persisted to S3 or a history table, so you can reconstruct the state of any item at any point in time. This is event sourcing in practice. And finally, cache invalidation. When data changes in DynamoDB, a Lambda can automatically invalidate or refresh the relevant entries in ElastiCache or CloudFront. Let me show you the architecture so it clicks visually. On the left, we have your DynamoDB table where your application reads and writes data. Every write operation flows into DynamoDB Streams in the middle. The stream is sharded, meaning it can be processed in parallel for high throughput. Records live there for 24 hours. On the right, AWS Lambda is configured as a trigger. It polls the stream, batches the records, and invokes your function. Your Lambda then sends the processed events to downstream services. Could be S3 for storage, Elasticsearch for search, SNS or SQS for messaging, or another DynamoDB table for aggregation or replication. The key thing here is that you, the developer, only write the Lambda logic. DynamoDB manages the stream, Lambda manages the polling. You just react to the events. Alright, let's get hands-on. Step 1 is enabling the stream to your table. You can do this in two ways. Through the AWS console, go to DynamoDB, select your table, click the Export and Streams tab, and then under DynamoDB Stream Details, hit Enable. Then pick your view type and save. Or if you prefer the command line, which is great for automation and infrastructure as code, here's the command. You can call AWS DynamoDB update table, pass your table name, and specify the stream specification. In this case, we are using new and old images. After enabling, DynamoDB will give you a stream ARN. You will need that to wire up your Lambda trigger in the next step. Now let's look at the Lambda handler code. This is the heart of your stream processor. The Lambda function receives an event object that contains a list of records. Each record has an event name, which is either insert, modify, or remove, and a DynamoDB object with the actual data. Let's walk through it. We loop over every record in the batch. First, we grab the event name. Then we get the DynamoDB payload. For an insert event, we access new image that's a full new item and process it. In this example, we are just printing it. But you would replace this with your real logic, indexing to Elasticsearch, sending an email, writing to another table, whatever. For a modify event, we get both the old image and the new image so we can compare what changed. And for a remove event, we get the keys, the primary key of the deleted item, so we know that was removed. Finally, we get a 200 status code to tell Lambda the batch was processed successfully. Before you ship this to production, let me share 6 best practices that will save your pain later. 1. Choose the right view type. Don't default to new and old images if you need only keys. Every byte in the stream costs money and bandwidth. 2. Make your handlers idempotent. Lambda carries at least once delivery, which means the same record could arrive twice. Always design your logic to handle duplicates gracefully. Use an idempotency key or a conditional write. 3. Monitor IteratorAge. This is a CloudWatch metrics that tells you how far behind your Lambda is from the tip of the stream. If your number is high, your Lambda isn't keeping up and you need to tune batch size or concurrency. 4. Tune batch size and parallelism. You can set your Lambda's batch size up to 10,000 records and set parallelization factor up to 10 to process multiple shards concurrently. 5. Configure a dead letter queue. If your Lambda fails after retries, those records go to DL an SQS queue or SNS topic, so you can investigate this and reprocess them. Without a dead letter queue or a DL queue, failed records block the shard. 6. Stay within the 24-hour window. Stream records expire after 24 hours. If your Lambda goes down and you're not consuming records, you could lose events. Set up CloudWatch alarms on IteratorAge to catch this early. Alright, let's wrap up with key takeaways. DynamoDB Streams captures every item change in a time-ordered sequence of records. You get 4 view types to choose from depending on how much data you need. Records are retained for 24 hours and integrate seamlessly with the AWS Lambda. Streams unlock powerful patterns like real-time replication, search sync, event-driven notifications, audit trails and cache invalidation, all without polling. And in production, remember idempotency, IteratorAge monitoring, and a dead letter queue are your 3 must-haves. That's it for today's video. If you find this helpful, smash that like button and subscribe so you don't miss the next one. We are going deep on DynamoDB global tables next. Drop any questions in the comment. I read every single one. Thanks for watching and I'll see you in the next one.